Good evening. We're going to start on section 12.3 tonight, liquids and solids. We're only going to go through liquids. I will cover solids with you next week in class when I'm back. Objectives for this entire section are to contrast the arrangements of particles in liquids and solids, describe the factors that affect viscosity, probably want to know what viscosity is, explain how the unit cell and crystal lattice are related. Review vocabulary. I hope everyone's familiar with what a meniscus is. This is the curved surface of a column of liquid. So if you're measuring something out in a graduated cylinder, so you have your graduated cylinder here, and you've filled it up with liquid to this point, you're going to have this curved line with where all your liquid is filled up. This line is called the meniscus, and you read from the very bottom of the line, not from the top of the line. Okay? New vocabulary. Again, this will be for you tomorrow in class, and you can get all these down then. Viscosity, surface tension, surfactant, crystalline solid, unit cell, allotrope, and amorphous solid. The main idea for this entire section: the particles in solids and liquids have a limited range of motion and are not easily compressed. All right, forces of attraction keep molecules closely packed in a fixed volume, but not in a fixed position. So forces, remember, they're going to be pushing in, keep the molecule closely packed they're going to stay in the same volume. They're going to stay in the same shape, but they're going to be able to still move around. Liquids are much denser than gases because of the stronger intramolecular forces holding the particles together. So all those intramolecular forces that we discussed yesterday and that you heard about today in the video, that's what's going to be holding them together and making liquids weigh more, as well as way more than gases do. Large amounts of pressure must be applied to compress liquids to very small amounts. So whereas it doesn't take as much pressure to compress gas into a propane tank, it takes a lot more pressure to compress water into the same size. Fluidity is the ability to flow and diffuse. Liquids and gases are fluid. Don't think of fluids as just liquids. Okay, fluid means it can move around. Viscosity is a measure of the resistance of a liquid to flow and is determined by the size of the intramolecular forces, the size and shape of particles, and the temperature. Okay, so viscosity, the measure of the resistance of a liquid to flow. Okay, so how likely is it to move around, to be fluid? And it's determined by the type of intramolecular forces. So are they dipole-dipole? Are they hydrogen? What are they? The size, and also the shape of the particles. Okay? And most importantly, we don't want to forget this when we're discussing any of these states of matter, is temperature. The stronger the intermolecular attractive force, the higher the viscosity. Larger molecules create greater viscosity. So if we're talking about higher viscosity, stronger intermolecular forces, as well as larger, how big the molecule is. The larger it is, the greater the viscosity. Long chains of molecules result in a high viscosity. So if we have a fatty chain, okay, that's going to be really long, a fatty acid chain, that's going to also have a higher viscosity. Increasing the temperature increases viscosity because the added energy allows the molecules to overcome intramolecular forces and flow more freely. So as you increase the temperature, the ability for it to move around also increases. It becomes more fluid. Surface tension. When we're discussing water and hydrogen bonds, you can't get away from surface tension. Okay, that's one of the most interesting properties of water, is its high surface tension. This is the energy required to increase the surface area of a liquid by a given amount. So surface tension can be seen when you see an insect sitting on water. They can actually, the hydrogen bonds are held together so tightly that it creates a surface that they can literally sit on. When you were doing your lab with the pennies, and you were putting drop by drop by drop of all the different liquids on there, the water definitely had a lot more if you did it correctly. That is the surface tension of those hydrogen bonds pulling together. Surfactants are compounds that lower the surface tension of water. Okay, so these are things that make water not have that cohesion that it would normally have. Remember, cohesion are things sticking to each other. Adhesion are things sticking to something else, like the sides, the walls of a container. So cohesion, the force of attraction between identical molecules. Adhesion, the force of attraction between molecules that are different. And capillary action. This is what you see when you use a pipette. If you put a glass pipette into water, or we do this in the lab sometimes with blood, if you put a capillary, a very thin tube of glass into a vial of blood, the blood will automatically begin to go up the capillary on its own without having to have any kind of a suction. Capillary action is the upward movement of liquids into a narrow cylinder or capillary tube. So when you're using a pipette in the lab, you obviously have suction that you're using. But if you have a glass pipette, and we don't use a whole lot of them, they will automatically pull the liquid up. And that's adhesion working. Okay, believe it or not, we are at the end. I didn't realize that's all we had. No questions at the end for tonight. And tomorrow in class, again, you'll watch a video, you'll do some questions. When I come back, you won't have any homework tomorrow night. No homework for the weekend. And when I come back on Monday, we'll finish up this section and talk about solids. Have a good weekend.